Hello, this is Mrs. Palyuka again. We are going to go through 04.01 ordered pairs. This is a new lesson module in a new unit on the coordinate plane. So here we have, it says, meet Ken. Ken and his family go on a camping trip at a local state park. When they arrive at the ranger station, they are given a map of the park. Each place to visit in the park is marked on the map. Ken looks at the map and is interested in hiking to some points, but staring at a map full of horizontal and vertical grid lines is confusing him. He did notice that each location has a pair of numbers. Some are positive, some are negative. Can that help him understand the location of the different sites he needs to visit? Let's take a look at Ken's map to the left. Ken has a hunch that there is something about these pairs of numbers and their signs that reveal information about their location on this map. Let's continue on this lesson to see if he is right. The lesson objectives will be, after completing this lesson, you will be able to say, I can recognize the signs of coordinates in an ordered pair or compare two ordered pairs. I can indicate in which quadrant of the coordinate plane the ordered pair will be located. I can determine relationships about how ordered pairs are reflected across axes. Signs of ordered pairs. Let's take a look at the locations on the map. Notice the center of the map is where the bold horizontal line and the bold vertical line cross over. This location is numbered the ordered pair 0, 0. Recall that the number 0 is neutral, so it is not positive or negative. So why are other locations numbered the way that they are on the map? So let's look at this map here. The part that they're talking about would be right here where my cursor is pointing, where it says the ranger station. So this would be your horizontal axis. This is your vertical one. So 0 would be right there where both of them meet. So they do have a number line help here. I know I haven't forgot about the remember part, but let's look at this part here. So it gives you a reminder that the number line goes,
What do you want me to play?
Alexa, stop. Sorry, my Alexa turned on. The number line goes forever in the negative direction and it goes forever in the positive direction, which is why there's arrows on each end. Okay. The number line is a one-dimensional graph because it maps only from left to right. Okay. And if we had a vertical number line, it would go up or down. The coordinate plane is two-dimensional. It maps left to right as well as up and down. So if I had another number line and I were to put it right here through the 0, I would then have my coordinate plane. So going back to the screen here, when working with a horizontal number line, numbers to the right of 0 are positive and numbers to the left of 0 are negative. For a vertical number line, those are the ones that go up and down, above 0 is positive and below 0 is negative. If you need to recall information on a number line, make sure you review the information below, and we just reviewed that part. Let's go ahead and look at Ken's map again. It says this map combines two number lines together. This is the reason that each location is represented by two numbers instead of one. You can identify every point on a grid using two numbers, which are called coordinates. So we're going to go ahead and play this part.
For a grid like this, coordinate points are written inside parentheses, separated by a comma. For example, the lagoon is located at 2, 3. These coordinates are called an ordered pair. The first number in an ordered pair is the x-coordinate, which tells you where the point is along the x-axis. The second number in an ordered pair is the y-coordinate, which tells you where the point is along the y-axis. The location of a point, left, right, above, and below, in relation to 0, will determine the signs of coordinates.
Your first goal with Ken is to be able to read ordered pairs and recognize the signs of the numbers. You can describe the location of points in relation to the origin. Now the origin is right there in the center where the ordered pair 0, 0 is. The coordinates in an ordered pair are similar to a set of directions. Let's look at a couple of examples to help you identify the signs of x and y coordinates. So let's review before we do that over here, an ordered pair. There's a reason why it's called an ordered pair is because you read it in a particular order. Ordered list of two numbers that describes the location of a point on a coordinate plane takes the form of the x coordinate goes first and then the y coordinate goes second. Now if you think about alphabetical order, x comes first, then y, so you always give the x number first and then the y number second. So let's look at our first example. Point A is located at the coordinates -2, 4. Are the x and y coordinates positive or negative? So if you recall, I said that they're always given in a particular order. The x number is always the first one. That one happens to be the -2. The y number is the second number. It's always going to be in that order. That one happens to be a 4, which is a positive 4. So to answer this question, are the x and y coordinates positive or negative? Let's talk about the x coordinate. It says -2, so therefore it is negative. The y coordinate is 4, just a plain old 4, so therefore that is positive. And of course, this just tells you everything that we just got done saying. Let's go ahead and look at example 2. Let's say that there are 2 points, A and B. Point A is located at the point, the ordered pair, -10, -4. Now pay attention to the fact that both those numbers are negative. And point B is located at the point -10, +4. Describe how they are different in terms of their x coordinates and their y coordinates. So they're talking to you about how these 2 points are different. You're comparing them. They're both their x and their y coordinates. So let's look at the x coordinate. The x coordinate on the first one is -10. The x coordinate on the second ordered pair is -10. So their x coordinates are both negative and they're both the same. Now look at their y coordinates. On the first point, point A, the y coordinate is -4. The second ordered pair, the y coordinate is 4, +4. So we know that those are not the same. This one's positive or negative, excuse me, and this one is positive. So they're different. So when we're comparing, point A located at the ordered pair -10, -4 has both negative x and y coordinates. Point B located at the point -10, 4 has a negative x and a positive y. This means that both points A and B have negative x's, but they differ in the signs of their y coordinates. The coordinate grid by quadrants. So I want you guys to think about the word quad, Q-U-A-D, means 4. Okay, so quadrants. So before Ken can use his map to get to different locations, he needs to understand how to read the grid. He knows how to read the sign of the numbers in an ordered pair, but what else does this reveal to him? In what direction is the lagoon located compared to the ranger station? Let's take another look at Ken's map. So we're going to go ahead and, so this is a big visual of his map. So he's talking about the ranger station, which we've already determined is at the origin, the ordered pair 0, 0, and he wants to go to the lagoon, which is over here. So the part that they're talking about how this a coordinate plane is broken up into 4 quadrants, those are the 4 parts. This is one part right here. This is the second part, the third part, and the fourth part. So, and we're going to see this in just a second, but the top right is quadrant 1, quadrant 2, quadrant 3, quadrant 4. I kind of think of it as a big C. C for coordinate plane. You start here and you make a C, and I wish I could draw on my computer screen. If that is an option, I'm sure it is. I don't know how to do that. So let's go ahead and have a look here. Recall this grid shows horizontal and vertical number lines crossing over each other. So here's your horizontal, here's your vertical. This is known as a coordinate plane. Let's take a look at what a coordinate plane is and all of its properties. So here's our first one.
A Cartesian plane, also known as a coordinate plane or coordinate grid, is a two-dimensional graph made up of intersecting horizontal and vertical lines.
The two major intersecting lines on a coordinate plane are called axes, axis if singular. The x-axis is the horizontal number line. Okay, so that is this guy right here. So you can see that they have it labeled. So this is the x-axis. The y-axis is the vertical number line. Now, if you think back to the previous lessons, we typically would use a horizontal number line just to plot locations and numbers. The vertical one we use when we talk a lot about altitude, like how high or low something is. This would be sea level. Temperatures kind of work better with vertical number lines as well. The origin is where the x and the y axis intersect. It has the ordered pair of 0, 0 quadrants. So the two axes split the plane into 4 sections, and each section is called a quadrant. Quadrants are usually numbered, such as 1, 2, 3, and 4. However, quadrants can also be named with letters depending on the context. So we typically will call these quadrants by numbers, and you're going to notice here, I'm going to highlight this part, and there's one over here, but they use Roman numerals. So the 1, which is over here on the top right, is Roman numeral 1. You've got Roman numeral 2, Roman numeral 3, and Roman numeral 4. We don't use Roman numerals a whole lot nowadays. Sometimes you might see it on a clock, especially if you go into a grandparent's home. You might have some in your own home that use those Roman numerals. Super Bowl every year is labeled with Roman numerals, and there's other things out there. I just can't recall them right now. So quadrant 1 is the one in the top right-hand corner. In this quadrant, both numbers are positive because you would start at 0. You travel to the right first before you would go up. So both numbers, both the x and the y, would be positive because these would be your x numbers. These are your y numbers. Now I'm going to go back to the origin. If I'm going to the left to quadrant 2, my x number is negative, my y would be positive. So this is quadrant 2. Quadrant 3 is down here in the bottom left. So if I start at the origin, I have to go left, which would be negative, and down, which would also be negative. So in quadrant 3, both the x and the y numbers are negative. In quadrant 4, you have a positive x, negative y. And a point's location on a coordinate plane is represented by an ordered pair. Usually points are labeled with a capital letter, especially if there is more than one point on the grid. All right. When you are trying to identify the quadrant in which a point is located, all you need to determine is whether the x and y coordinate of the point are negative or positive. Use this flip card interactive to see how each quadrant is identified. Okay, so let's look at this first one. We're going to start here because I like to start at quadrant 1. So quadrant 1 is this one right over here. You can see there's a red dot up in the top right-hand corner of this coordinate plane. So when I click on this, quadrant 1. In this quadrant, the x coordinate is positive and the y coordinate is positive in an ordered pair, x, y. For example, the ordered pair 3, 5. Notice they're both positive numbers. Now let's look at quadrant 2. So now we were here and we went to the left. Quadrant 2. In this quadrant, the x coordinate is negative and the y coordinate is positive in an ordered pair, negative x, positive y. For example, you would have the ordered pair negative 3, 5. Quadrant 3, notice you're in the bottom left corner. In this quadrant, the x coordinate is negative and the y coordinate is negative. In an ordered pair, negative x, negative y. For example, you would have the ordered pair negative 3, negative 5. And our last quadrant, quadrant 4, which is on the bottom right, In this quadrant, the x-coordinate is positive and the y-coordinate is negative in an ordered pair, such as x, negative y. For example, you would have a positive 3 and a negative 5. If Ken texts his mom and says, I'm in the same quadrant as the campground, in which quadrant would he be located? So we need to go ahead and look at Ken's map again. So I'm going to click on this in a second. So he's saying he's in the same quadrant as the campground. So let's find the campground. Campground is right over here. So which quadrant is he in? Notice that both numbers are negative. So I always like to start at the top right. Okay, Quadrant 1, Quadrant 2, Quadrant 3. So the campground is in Quadrant 3. I don't need that screen. Let's go back. And then we can always check to see. He would be in Quadrant 3, so we were correct. If his next text said, Mom, I walked over to the picnic area. Can you bring me some water, please? To which quadrant would his mom have to walk? So let's look at our map again. Oops, sorry, I meant to click on the map. But let's go ahead and have a look at it again. So he is at the picnic area. So the picnic area is up here. So that would be Quadrant 2. This is number 1, number 2. All right, let's look at some examples here. Let's look at some more examples to identify quadrants using all types of numbers. So example 1. On this grid, point C is located at the ordered pair 3.5, negative 2. In which quadrant is the point located and how do you know? All right, so it's right here. So think about where is it located. So start at the top right, 1, 2, 3, 4. Remember I said I like to think of it as a C. So I start here, 1, 2, 3, 4. So yes, we are in Quadrant 4. Let's look at example 2. In this coordinate grid, can you think of another point that is in the same quadrant as point B? Now, they changed this question. They're not asking you which quadrant it's in. It is in Quadrant 2. They're asking you to come up with another point. So there would be several right answers to this one. But any point that you would choose, your first number has to be negative. So it would be a negative x value and a positive y value. So an example could be any of these that they have here. You could say negative 3, 2 and 3/4. You could say negative 2 and 8/10, 4. Negative 1 and 4 2/10, or negative 3/10 and positive 2. So in each of these examples, I want you to notice that the first coordinate was negative. The second coordinate is positive. All right. Mirror, mirror on the wall. While enjoying the time at the scenic overlook, Ken is looking at himself in the water and he makes a few observations. When you look at Ken and compare him to his image, things are on opposite sides. For example, his right hand is raised, but in the image it appears to show on the left. So if you guys think about it, if you go run to a mirror right now and you look at the mirror and you wave to yourself in the mirror with your right hand, the person waving back is waving back with their left hand. Kind of weird, but that is what a reflection is. And so I want you to think about that. So it's the opposite. If we're waving with our right hand, the opposite of our right hand would be our left hand. So keep that in mind as we're talking about reflections across these axes in a moment. You can reflect points on a coordinate plane as if there was a mirror on it. The two most common ways are reflecting across the x-axis or the y-axis. All right, so let's have a look here. When you reflect a point across the x-axis, the x-coordinates of the two ordered pairs are the same, and the y-coordinates are opposite. So reflecting across the x-axis is the same as taking the opposite of the y. So remember, this is your x-axis right here, this horizontal line. The two ordered pairs that they have here that they're showing, they didn't give you numbers, but what they just gave you is a positive x, positive x, negative y down here. If you're reflecting across the x-axis, it's as if you're going to jump across that x line. So you're keeping the same x number. So I want you guys to notice that this is a positive x. So if you're reflecting across the x-axis, you keep the same x number. It's the y's that are opposite. So positive y, opposite of positive y would be a negative y. So when we're talking about reflecting across the y-axis, this is your vertical line. It's the y numbers you keep the same. So if you jump across the y, you reflect across the y, you keep those numbers the same. You're doing the opposite x. So if you look at this one, all right, notice our y's are the same. They're both positive. It's the x's that are opposites, negative x, positive x. That's because we jumped across the y-axis. So keep that in mind. That's really important because I know you're going to get a lot of questions or some questions on that quiz at the end of this where they're going to ask you to reflect. And my suggestion would be is print that summary or have it open in a different window off to the side and refer to it when you're taking your quiz. But if you're asked to reflect across the y-axis, you keep the y. You do the opposite of the other number, which is x. Let's take another look at Ken's map. So here we go again. Do you notice any similarities or differences between the lagoon, located at the ordered pair 2, 3, and the scenic overlook, located at the ordered pair 2, negative 3? So the lagoon is in Quadrant 1, and the scenic overlook is in Quadrant 4. The x-coordinates of both ordered pairs are the same. So the lagoon is 2, the scenic overlook is 2. So those are the same x-coordinates. The y-coordinates are different, but the only difference is the sign. This one's positive, this one's negative. The lagoon is at a positive 3, while the scenic overlook is at a negative 3. So you could say that the location of the scenic overlook, this guy right here, is a reflection of the location of the lagoon across the x-axis. So remember, if it's talking about a reflection or being reflected across an x line, you're jumping over it. So it's important that you know that this is your x line, your x-axis. Let's look at a couple of examples of reflections as they relate to ordered pairs. So here it gives you the definition of a reflection, which is a mirror image of a point that is created across a line, such as one of the axes. All right. So here are other examples. So this is the part where what I would suggest that you do is on that piece of paper you should always have out when you're doing math, just jot down what you think the answer is. So if I go too fast, just pause the video, all right, and then check your answer. Example 1, point negative 5, 3 is a reflection of the ordered pair negative 5, negative 3. Across which axis is the reflection occurring? So you want to look for which number is identical, the same, meaning the signs. So if you look here, the negative 5 is the same on both of them. They're both negative. So since the negative 5 is the x number, this is being reflected across the x-axis. Ta-da! Here's your x-axis. You're jumping across that x line. So the x-coordinate is the same, y is the opposite, so the points are reflected across the x. So remember, you're looking for what the same is. Let's look at example 2. Same type of question, okay, a little different here. Point negative 3, 4 is reflected across the y-axis to get point K. What are the coordinates of point K? Okay. So the key word here is y-axis. So if you're reflecting across the y-axis, you keep, ignore that. If you're reflecting across the y-axis, you're keeping the y number. This is the y number right here, the y coordinate 4. So when I write my new ordered pair, I'm going to keep the 4, positive 4. It's the x that I need to have the opposite of. So what's the opposite of negative 3? Positive 3. And that's where we have it right there. So the ordered pair would be positive 3, positive 4. Let's look at example 3. Point negative 4, 2 is reflected on the coordinate plane across both axes to get point M. what are the coordinates of M? Okay, so if we're reflecting this across if we're reflecting across both axes, now this is the part where you definitely want to write some stuff down. So, for example, if I've got the ordered pair -4, +2, and I'm reflecting them across both axes. So let's say we're going to jump across the x-axis first. That means I keep the -4, but then I have a -2. Now this time I want to reflect across the y-axis. So remember, my -2 turned into, my +2 turned into a -2. So that means I keep that -2 and I do the opposite of -4, which is the ordered pair 4, -2. Essentially, you're taking the opposite of both, guys. So if you're being asked to reflect across both axes, both of them, you're going to change the sign on both numbers. So +4, -2, which is what you get here, +4, -2. And last example, a point is located in the second quadrant. So remember, that's the top left, and it is reflected over the y-axis. Determine an ordered pair that will be in the same quadrant as the reflected point. All right, so if you're in quadrant 2, remember that is the top left. If you're jumping over the y-axis, that's the vertical one. So it's the one that's going to be up and down, right? So if you're jumping over that line, you're landing in which quadrant? Quadrant number 1, which means that both coordinates have to be positive. So this is where you're at. If you're jumping, okay, across the y-axis, which is this guy right here, so you're going to take this point and jump over here. You're in quadrant 1, and you just need to pick any two points, but both have to be positive. And the example that they gave here is the ordered pair 3, 5. Okay, so this is the part where I want you guys to complete these problems on your own before checking your answers. So I'm not going to go over this part here. So this is the part where you're going to go into the actual lesson module. You're going to skip to page 4 at the very bottom, and I want you to work through these 3 examples that are down here. So it's pointless for me to go through them and then just show you the answers. I really want you guys to give them a try and then check your own work. This is really the only way you're going to know if you understand these problems well. All right, let's go on to practice. So again, there's additional practice that reviews everything that we just talked about. So on this one here, they're going to ask you to, they give you some drop menus, and then remember to submit it. Now, once you submit, keep in mind there's 6 additional problems down here. So once you submit something, you're going to keep clicking the next button till you get through all 6 problems. Again, don't skip this part, guys. This is the part that really shows you right away, hey, are you understanding this or are you not? And if you're finding that you're getting a lot of mistakes or having a lot of errors, this is where you could reach out to a teacher in discussions or join one of the Zoom sessions that you can ask questions on as well. Okay, and then our last part. So we're reviewing the lesson objectives. The first thing you need to do, remember, is so that you can recognize the signs of coordinates in an ordered pair and compare 2 of them. So we're talking about positive or negative. You could indicate which quadrant each of those coordinates are in. So remember, there's 4 quadrants, 1, 2, 3, and 4. And you can determine the relationships about how the ordered pairs are reflected across the quadrants. Okay, there's a lot of vocabulary that was brought up in this lesson: the ordered pair, axis, Cartesian plane, which we just call a coordinate plane, the origin, which is the center, 0, 0, quadrants, there's 4 of them. Your x-axis is your horizontal axis, your y-axis is your vertical axis, and then a reflection, which is the mirror image. So here's that wonderful summary that your teachers keep referring to. So honestly, you guys, if you look at this, it really does break things down for you. It talks to you about reflections here. It gives you examples. And this is really important because it does help you when you're taking that quiz. All right. So this is the end of this lesson. I am going to do a separate short lesson where it's going to be me giving you specific examples, so you'll see some of my writing. And I'm just going to recap this a lot shorter and just kind of straight to the point with other examples. So I would suggest that prior to taking the quiz that you look for that short video. I'll try to make it about, no more than 5 to 10 minutes long for you to review before you take that next lesson. All right, we'll see you guys next time.